Hey, welcome to another adventure in old code, the place on the internet where we usually take a look at old Qbasic code we wrote back in the day, and we laugh, we cry, we cringe, but mostly we just hang our heads in shame at what came out of our brains. Today, we're not going to do that, and I'll explain. So, way back in the day, 100 years ago when I was in grade 7, we had an old 386, and I was learning the DOS prompt. I spent hours on the DOS prompt exploring the hard drive. That was one of my favorite things to do, is to explore the hard drive. I knew the basics, I knew how to change directories, and I knew I could run any file that ended in exe, com, or bat. I didn't know what these things meant, but I knew I could execute them. You could actually do something with them and they would produce something some of the times. Some of the scripts and programs required an argument, and of course I didn't know what that was, and so it just didn't do anything. But others, they actually launched an application. Seeing as how this was a used computer, there was lots of stuff on the hard drive for me to explore. I didn't know anything other than the extreme basics, and so one day I stumbled upon this. I found myself in the DOS directory, and I was looking, wow, look at all these exe files. And so I learned very quickly that I could, instead of going dir star.exe, because that would sometimes produce output like this, and I couldn't see everything, I could go dir.exe as a shortcut. Okay, that's the first thing. But then you can also do /w to give them all in a nice little grid there. Anyway, whatever. I was doing this and I opened up Qbasic and I didn't know what it was, and I opened it up and was like, okay, wow, this is amazing. What is this? I have no clue. Remember, I'm 13 years old. And so I look and I go, or maybe I should swap my camera here. Wow, I wonder what happens if I open a file, and I'm presented with these 4 files. And I had no idea what they are. And so I thought, oh, okay, I'll just go to Gorilla. And then I went to Gorilla. And it's like, okay, what even is this? Your mission. I don't know what this is. But as a 13-year-old, I was extremely curious. And so I went through the menus and I'm like, oh, wow, what does this mean? I don't even know what this means. Run. Wait a second. What is start do? And this is when my world changed. At this moment, I realized, oh my goodness, what even is this? I said, view the intro. And I stared at this, thinking, what did I just discover? When I realized I discovered a new game on my computer, I was in heaven. There was nothing could compare to it. And I remember it was a weekday night. And I remember it was a weekday night because I had to go to school the next day. And I remember being absolutely devastated that I'd found this new game. And it was late at night and I had to go to bed, and I wasn't going to be able to play this game until after school. It was devastating to me. Just the dread of having to go to school. So anyway, that's a big, long introduction. So, okay, so that's my history with Gorilla. Now, I didn't know anything about Qbasic. Oh no! I didn't know anything about Qbasic. Years later in high school, we started to learn Qbasic. Just a second, I'm going to turn my AC off. Computer, make it warm. There we go. I didn't know anything about Qbasic in high school. We started to learn Qbasic, and I'm like, wow, this is that thing that Gorilla was made in. And so I tried to go back to the source code and understand this thing, but I couldn't. I couldn't. It was too convoluted for me. The code was too hard to understand. And after I graduated, and again, I only took one semester of Qbasic, I would revisit Gorilla every few years trying to make sense of it, and I never could. And since then, I've long since forgotten about what the code looks like. But I did go on and do more Qbasic things. The problem is when I wrote a Qbasic program, I didn't have the internet. I only used the subset of operations that I learned in school and what I could glean from the help file. So the help file was pretty cool. And I did spend a lot of time just perusing this, not really knowing exactly most of the time what these things are. But anyway, I would revisit the source code for Gorilla every so often, trying to make heads or tails of it, and I couldn't. And that was it. Now, I haven't tried in a long time to look at Gorilla, but I'm going to assume that now that I'm over 40 and I've been an actual real life software developer for over a decade, I can probably figure this out. I'm going to assume I can figure this out. So this is what we're going to do on today's episode, and I'm sure it'll go longer than just one episode, but hey, we'll see what happens. Okay, let's get started. So Qbasic Gorillas. I'm going to assume that Microsoft wrote this because of the copyright in 1990. So I was 8 years old when this thing was written. Your mission is to hit your opponent with the exploding banana by varying the angle and power of your throw, taking into account wind speed, gravity, and the city skyline. Speed of this game is determined by the constant speed const. If the program is too slow or too fast, adjust the speed const equals 500. Line below. The larger the number, the faster the game will go. This sounds a lot like the intros that I put to my games. So clearly there weren't, fixed frame rates or anything back then. So this is kind of, yeah. 1 second. I think my mic might be a little loud here. Check 1 2. I think that's probably better. Okay. I'm expecting to learn a lot. I've already learned in the second paragraph that Qbasic's got a const. A const variable. Oh, whoops, there. Now I'm active here. Okay, to run this game, press Shift F5. To execute Basic, Alt FX. To get help on a basic keyword, blah, 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 blah. Okay, so let's go through this line by line, and the things that I will let you know what's new to me, and anything that hasn't been in my videos, I'll try and explain. So here we go. Let's just figure this out ourselves. So this is long. This is the main subroutine, but we have all of these other things. So this is pretty cool. I'm excited. Okay, let's go up here. Def int A to Z. This will tell the, I want to say it a compiler, but it's the interpreter. It will tell Qbasic that any variable starting with a letter between A and Z, so basically all variables are going to be integers. There's no fractions, no decimal points, just integers by default. And I think I got that right. Sets the default data type for variables and function procedures. So we're starting out with everything's an integer unless we specify otherwise. Okay, here's some subroutine declarations. We've got do sun, and then we have a parameter. Now this is something that has never appeared in my programs. It appeared in the later ones, but not in the earlier ones, and I don't think I've done a video where I'm taking any parameters at all in any of my subroutines. So I don't have much experience with functions. A subroutine that takes a parameter, I think, is. Oh, no, 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 no. No, no, no. A function returns a value. A subroutine doesn't return a value. So it's like the void. Subroutines are like void methods in today's lingo. And functions actually return something. Anyway, mouth is going to be a variable, and we pass that into the do sun subroutine. So if I go to do sun, we see we have a parameter mouth. So if true, draws 0 O mouth, else draws a smile mouth. Well, that's nice. Okay, and so that's basically how you accept parameters and use them. Okay, so set screen end game center. That's kind of nice. Center probably centers text. Intro, sparkle pause. Huh. Get inputs. Okay. Did we? Yeah, we did. Okay, yeah. Player one string, that's going to be the name of player one, name of player two, and the number of games you're playing. Play game, do explosion. Okay, so now this is interesting. What are these number signs, these hash symbols? So I think, let's go here. Location of explosion. Now I know an integer you would append percent sign, but everything's an integer. So what is the hash mark? Dollar signs are strings. Types, is that what I'm going to look at? Type statement. No, it's not a statement. Const keyword, blah, blah, blah. What is this? Here, let's go to the defint statement. Sometimes it has links to other ones. See, this is using the hashed variable equals radius to 0 step -1 times inc. Inc equals 0.5. Okay, so this must just be a single. This is probably why I've never seen it before. By default, if you don't have a def int statement, like this one, by default, everything's a single floating point number, a number with a few decimal spots. I suspect in the world where we change everything to an integer that you have to use the number sign to specify a single. I'm going to make that assumption. Maybe we can find that in the contents here. Qbasic keyboard time. Index. Single keyword. Specify shared static subcommon element function type. Maybe just type. Maybe we'll just look at the type. No. Okay, I'm going to assume that's hash is a single. We'll just do that. Oh man, this is cool. I've never seen that. That's an exclamation mark. Oh man, there's so many different kinds. See, that's the trouble. Qbasic is very, very. They kind of want to be Python, but you can't. It is a strongly typed language, so it needs to know what you're using. So instead of requiring everything to have a type declaration, you have a default, and then anything else Yeah, you'd have to put these. You have to put these symbols on. I don't think you have to put these symbols on. I'm assuming that's a long or something like that. Can I do this? Yeah, I think you could do something like this, but this is just a shorthand. I'm going to assume. I'm assuming the exclamation mark is a long. Okay. Anyway, get do shot explode gorilla. That sounds fun. Get n. Plot shot and calc delay. With an exclamation mark. Oh, yes, these are functions. Okay. So functions return a value. It doesn't just break up your code into small chunks. These will actually return a value. And so you have to tell it what type it's going to return. So if it has nothing, it's going to use the default, which in this case is int. But if you do have something, it's going to return that. So this will return a single. SCL. Thanks, Microsoft. What does that mean? Anyway, okay. Make all arrays dynamic. So this is something else. This is an advanced technique. Ooh. What does it mean by a dynamic array? Okay. So dynamic specifies that arrays declared in subsequent dim statements are dynamic arrays. Array storage is allocated dynamically while the program runs. Dim and redim usually provide a better way to specify whether arrays are dynamic or static. Okay. Dim and redim usually provide a better way to specify whether arrays are dynamic or static. Well, dim, we see that all the time. Declares an array of or specifies a data type for a non-array variable. Redim declares or resizes it. Yes, that's right. Redim. Okay, what is the difference? What is static and dynamic? Well, we know what dynamic. Okay, static is arrays declared in subsequent dim statements are static arrays. Array storage is allocated when you start the program and remains fixed. Okay, so if an array is dynamic, you can change its size using the dim and the redim commands. We see dim used all the time in my programs. Redim, you can just redimension it. Saying redim, the variable is now this size of array. But anyway, you can only do that with a dynamic array. And I guess it's a way to reuse an array that needs to be different sizes at various points in time. Okay, this makes everything dynamic. And this is interesting because it starts off with an apostrophe, which usually is a comment. So I'm going to take the assumption is that this is like a preprocessor command, or this isn't exactly Qbasic. The Qbasic runtime isn't going to execute this. This is going to be something that is set up in the runtime before Qbasic even starts to interpret the code. Kind of like a pre-compiler directive or something like that. Anyway, user-defined types. And again, this is, if you know what a struct is in C, that's what that is. This is just two integers being packaged together as a type. And so now you can talk about XY point as a type. And so here I can say dim temp as XY point. I can do that. Now temp, to get at the x coordinate, I would go temp.x coordinate equals. So it's just a way that you can keep related properties of an object together. But that's a very, very common thing in many different languages. Qbasic called them types. Okay, constants. Here we go. And they uppercase or capitalize all the constants. Okay, speed const 500. True is -1. What? What in the actual heck am I looking at? I didn't expect to find stupidity in this code. I mean, I'm sure this isn't stupid. Const true equals -1. So Qbasic doesn't have Boolean variables, doesn't have true and false. They're not actual real values. You used an integer, essentially, is what you did. You said, hey, this thing is 1, or it's usually you use 0 for false, or if you don't want to use 0, true is 1 and -1 is false. What am I looking at? True is -1? That's the weirdest thing I've ever seen in my whole life. Yeah, right. Okay, const false is equals not true. I did not know you could use the word not. That's kind of fun. See, look at this. Even Qbasic in their help says Boolean operators return a true, which is a non-zero, or a false, 0 value. Oh, so even negative values, as long as they're not 0, would be false. I guess C does something similar, but it's just janky to see true equals -1. Okay. Anyway, but yeah, you can use not to negate it. That's interesting. Okay. Hit self equals 1. Back attr 0. Object color 1. Window color 14. Sun attribute 3. Sun is happy? False. Sun shock? True. Right up, left up, arms down equals 3. Right up is 1 and left up is 2. Okay, global variables. Excellent. Okay, we have 2 arrays. This is really fascinating to me. They've got 2 Gorilla X variables and 2 Gorilla Y variables. Why didn't they just have 2 Gorilla variables? And each Gorilla is a type with an X and a Y coordinate inside. Like, this is something I did in my programs. This just doesn't seem that great of a way to do it. Why didn't you make a new Gorilla type? Microsoft, what are you doing? Okay, and then dim shared last building. So last building, that's interesting. It's a global variable. It's a global integer because it's not specified a type. Okay. Wow, we got more pi. There it is. Pi. So they're making their own pi variable. I don't know if, I guess Qbasic doesn't have pi as a built-in constant. Okay, anyway. Dim shared, we've got left banana, I'm guessing, right banana. And these ampersands, that I know, that's a long integer. So it's, I think it's like a 32-bit integer. Up banana and down banana. Graphical picture of banana. Thanks for that. Graphical picture of arms down. See, okay. Interesting. So, oh, right. These are variables, but they're X. What is X? What the heck is X? I don't understand. Huh. Okay, so the other thing is these are long. Okay, okay, hold on. These are long integers. All of these are arrays of X long integers. You say it's a graphical picture. How can they be long integers? Well, let's just hold that thought. These are 120 longs. Now, we should probably figure out what a long is, because I'm that's going to be important. Oops, to understand this. So let's go to long. Okay, so a long is a 32-bit signed integer variable. That means, I believe, we're going to get from minus 32,768 up to 32,767. That's what the signed means. It's got equal weight on both negative and positive values. So, yeah, okay, that's fine. It's a 32-bit signed variable. So this is 32 bits, and we have 120 of them. That's a lot of area to do some kind of a bitmap kind of a thing. Anyway, we'll see how they're using that. Okay, gravity is a single, and it's shared, and wind is, oh, it's Kate. Okay, so they seem to have a convention of doing what's called Pascal case, where separate words, each of the words are the first letter of each word is uppercased. That's generally called camel case, but Pascal case also requires the first letter of the entire string to be capitalized as well. They seem to be using Pascal case for global variables, except if it's like a mathematical constant like gravity or pi. Literal constants are completely uppercase, and subroutines are also Pascal case. Okay, so that's interesting. They've chosen, so wind. I mean, I guess that is some kind of a variable, but why isn't gravity a constant? Do you not have a constant single? Look at this. Pi is right here in their example. Why didn't they add pi to their const list? Okay, whatever. Screen mode variables, screen height, screen width, mode, max call. Okay. Color variables. Explosion color. All of these are global variables. Back color. Sun hit. Oh, what am I looking at? What am I looking at? This is hilarious. Okay, so obviously sun hit means the sun was hit with the banana, because you can do that in this game. So I'm assuming this is the sun height. Why they didn't just spell out the word height is beyond me. But what's even more hilarious is the very next variable is G height. And you can't even use the excuse that they're trying to keep variable names short, because this one's called explosion color. Ah, that's hilarious. Okay, match speed as single. So, like, literally, other ones you do that. Why are you? This is hilarious. I was expecting something polished and but this is like two different people did this and they did not look at each other's code. I don't know what for source control they had and collaboration tools, but my goodness. And this I'm telling you, this is right from the DOS 5 disks. This is legitimately what Microsoft shipped with. Okay, def fnran. So this is I would always do this as def fnr of x. It's a random number generator, but I would interesting. I would just do rnd times x. I didn't know the rnd function produced. Like, what's the one for? Yeah, rnd times 6 plus 1. This is how you simulate it. So what is this? What is rnd at 1? Okay, let's sorry, I want to try this out here. Let's randomize the timer. Print rnd, print rnd 1. What is this? Okay, here, let's clear the screen. Okay, let's print rnd 10. What does that do? Is this just a seed? Like, if I make these all 10, are they all going to be the same? No, they're not the same. What is this parameter? RNDN, a value that sets how RND generates the next round. Oh, it's right there. I could have read it. If it's less than 0, the same number for... Oh, fascinating. See, I'm learning all these kinds of things. So if it's less than 0, the random number is the same for any n. Greater than 0 or omitted, the next random number. 0, the last number generated. So greater than 0 or omitted are the same thing. So that's what their RND1 is. But if I... Hold on. I'm getting somewhere. RND 0, minus 1. And then I'll print minus 5. Are those... Fine, make it -1. Huh. And then, oops. And then the -5s. Interesting. So if it's a negative number, as long as the ends match, which is exactly what the help file said, as long as the ends match, you're going to get the same number. Wow, that's interesting. And then 0 is the last one generated. But what if I haven't generated any? 115. Here, let's print R&D. So this should give me the same thing twice. Fascinating. I didn't know that. That's cool. Okay, good. That's the random number generator. So they didn't need this one, but they put it in there because, I don't know, person number 2 working on this code decided to do that. Okay, def seg. This is set numlock to on. This is something new. What in the heck is this? So, sets the current segment address. Segment address used by bload, bsave, call absolute, peak, or poke. A value in the range 0 to 65,000. The address is omitted. Defseg resets the current segment address to the default data segment. So, okay, what this is this is saying here's a special area in memory that we're going to either read from or write to. And that's how a lot of these devices are accessed, to my limited knowledge. Devices are accessed not by saying, hey, computer, go to the keyboard and read it. The computer doesn't know what that is. But what happens is the keyboard is mapped to a memory location on the CPU, I guess, in memory and in RAM, perhaps. Not entirely sure. So take everything I say here with a grain of salt. But those are special addresses. And when you write special values to those special addresses, different things happen. So defseg just says, this is what we're, this is kind of the address that we're going to look at. If the address is omitted, I don't know, 0 through 65,000. So yeah, this is an address, 0. Okay. And this comment says that says set numlock to on, which is interesting. I mean, I know you can't see this, but numlock for me is off. I'll run the program. Let's just play the game. Numlock's still off. I don't know what that means. Okay. Whoops. I'm not entirely sure what is happening there. Whoops. Okay. Key flags equals peak of 1047. So peak returns a byte value stored at a specified memory location. So the address, in this case 1047, is the position relative to the current segment address set by defseg. So defseg is 0. This is literally the address 1047. You can also specify an integer byte. Okay, so we're reading the value stored at there. If key flags end 32, is this conjunction? Oh, this isn't a bitwise. Is it? See, key flags. What the heck is key flags? I mean, I know it's this value that you read, but okay. This is a bitwise AND. It's got to be a bitwise AND. What does peak return? Peak returns an integer. Okay. Okay. Sorry, I have to know this. So, if I say 32 or 32, is that going to print 0? No, that's not going to. Oh no, exclusive OR. Can I do an exclusive OR? That's going to print 0. And that's going to produce 32. Okay, so what if I did, we'll print 1 and 4. That should produce 5. No, that produces 0. 1 and 4. Oh, 1 or 4. No. 1 and 5. There, that should produce 1. Okay, that produces 1. So this really is a bitwise operation. If you don't understand what just happened, let me think. A bitwise operation is looking at the individual bits of a number. So for the number 1, let's just use 8 bits. 6, 7, 8. That's 1. Thanks, Qbasic. Okay, 1, 2, 3, 4, 5, 6, 7, 8. That's 1. The number 5 is, you have a 4 and a 1. So this is, top one is 1, bottom one is 5. If you don't understand binary, well, we're not going to go into it now. You'll have to look that up yourself. So this is the numbers 1, and this is 5. And when you AND them, you look column by column. If they both contain a 1, then your answer contains a 1. If they both contain a 0, the answer contains a 0. And if they contain different things, this is where the operation comes in. In an AND operation, both of them have to be the same. So this is 0 because they're not both the same. And then the rest are zeros, and you get, whoops, you're an undo. No, okay. And then you get a 1. If this was an OR, you would get a 5, because when you look at 1 or 1, you know, you still got 1. So it's 1. If at least one of them is 1, the answer is 1. None of the ones are 1 here, so that's a 0. This, at least one of them is a 1, so that's where you get a 1 there. Anyway, you go on, and you have exclusive ORs, which mean they can't both be the same thing. And you have other things. So that's what they're doing. That's what they're doing. Now, the question is, why are they doing this? Well, we just read from a special segment in memory, and we got back an integer. Oops. So we're looking at this, and we are ANDing it with 32. So we're basically looking at the topmost bit or the bottommost bit, however you want to look at it. We're looking at a chunk of 32 bits in memory. If we want to just look at the one in position 32, we AND it with 32 to see if that position is a 1 or a 0. So if key flags and 32, so if the 32nd bit of this memory address was 0, then we're going to poke. Okay, poking is the opposite of peeking. poking will write a value to that. So key flags is a special 32-bit segment of the memory, which is obviously going to define certain things, and it's going to speak to the hardware. And I guess the 32nd bit of this memory location dictates what numlock is, if it's on or off. And so if it's off, meaning the 32nd bit was 0, we are going to poke the number, which we get by taking key flags, what it originally is, ORing it with 32. So the use of OR here to write back to memory says keep everything about key flags the same, except flip the bit at 32. Not flip it, but take the OR operation. So if it was 0, it's now going to be 1. Now, the thing is, if it was 1, it's still going to be 1 too. This is absolutely unnecessary. So, yeah, I'm not sure running through 86box, my hardware emulator, this is actually, it didn't set my numlock, but maybe that's an incompatibility, 35 years after the fact, running in some emulation software. Anyway, that is what that's doing. And then we're def segging again. Oh, no. This doesn't have the 0. What is this? If the address is omitted, defseg resets the current segment address to the default data segment. Okay, so whatever it was pointing to before all this numlock nonsense, this block basically, I think, just sets numlock to on, which is exactly what their comment is. But that's how they're doing it. They're looking at that memory address. Now, this memory address, you probably had to look it up in a programming book or something, like a Qbasic book. I don't know if they also defseg, like, do they have a dictionary of keyboard scan codes? It's not really what I don't think they have a dictionary of, anyway, of what these special addresses are, but okay. Anyway, here we go. Let's get to the end of end. Nice. GOSUB. So essentially, what the heck in what the? Okay, I'm genuinely confused about that. Let's get to the end of this. We're gonna have to call it a day because this is already getting on in the day. But we'll swing by next time. Go after some of those other things. Okay, so that ends the def seg. Then GOSUB init vars. We're gonna look at these a little bit later. What the heck does GOSUB mean? GOSUB just means run this subroutine. And that's literally all it does. It's totally unnecessary. Branches to and returns from a subroutine. No, the label or line number. Label. Don't supply a label or a line number for return. The program continues execution of the following. Like, this is a subroutine, right? Not. It's right there. Holy crow. GOSUB can go to labels Wait a second. Doesn't Qbasic have a go-to command? This would run, right? Oh, but then it doesn't automatically return. Oh, that's why you'd use that. So you can't use a go-to because you want to run all the code in init vars and then return to run intro and get inputs and everything like that. And so you use this terminology, GOSUB. And GOSUB, if this were a subroutine, it would go to a subroutine. This is not a subroutine, it's a label. And GOSUB can go to labels. The label or the line number. You don't supply. Sub and call statements provide a better alternative to Go subroutines. Yeah, right. I thought this was a, so what I thought when I was saying that this is totally an unnecessary thing, I thought it was the call command, because you can call, like you can call subroutine, and that is totally unnecessary. You can just leave it out. GOSUB is different though. So GOSUB, so they've defined an init vars label, which is, you can't find it in when I hit F2, because these are the actual subroutines. This is actually down here as a label, and there's just some random code. Okay, anyway, I never knew that. Okay, then we call an intro. We get inputs, name 1, name 2. We'll look at these later. Gorilla intro, then you play game. So this is really initialize, show the intro, get the players' names, show the gorillas moving up and down, play the game, and you're done. So your whole gameplay actually exists within these 5 lines. And then we set the segment offset again. We're going to restore the numlock state. And this time we're going to poke key flag. Right. Because key flags was the original value. Now, we didn't change the value of key flags. We updated the value with an expression using key flags, but key flags is still the original value it was since we started the program. And now here we're restoring the state of numlock before we end the program. All right. Well, that was a long haul. Next time we'll start going into some of these things. We'll have to take a look at all of these funky things. But like always, we'll take this one line at a time as we call it. So we'll first talk about the init vars, and we'll go to the intro and the get inputs, Gorilla intro. Finally, play game. We'll discuss it all. So anyway, thanks for joining me in this adventure in old code. Have a great day, and we will see you next time.